In this video, we're going to be determining the molecular formula from the name of an ionic compound using a method known as balancing the ions to zero. And what we're going to be doing here is we're going to look at concepts that we referred to briefly in our last video. We said that the total charge, the net charge on each side of the equation, the reactant side and the product side should be the same, because we can't gain or lose charges, because that would mean that we're gaining or losing electrons. And the law of conservation of mass says that energy matter can't be created nor destroyed. We're not going to spontaneously create electrons and add to the charge or lose electrons. We can't just make electrons disappear and change the charge that way either. So the net charge between each side of the equation is going to be equal. In the cases of the problems that we're going to be solving, the net charge is going to be zero. So that means that both sides of the equation are going to have an overall charge of zero. And we showed how this is when we drew it out in this example. We said that aluminum and oxygen by themselves are uncharged. But then if we add a charge, anytime we add a charge to one, anytime we are taking away electrons from one, the other atom is gaining those electrons. So the electrons are not going anywhere. They're all still within this system here. But again, when one atom is losing electrons, the other is accepting them. So when one atom is becoming more positive, another atom is becoming more negative. So this next method is just a way of solving these without drawing everything out like this, but instead just looking at the charges only. So let's take a look at what that's going to look like, doing a few examples here. So let's do a very simple example to start. Let's do sodium and chlorine. So sodium and chlorine. So sodium, and to do this method, here, let's see. So sodium chloride, we're going to write sodium chloride. So sodium chloride is made up of sodium and chlorine. And to do this method, we're going to be looking at the charge that these elements have when they form ions. So we can refer to our periodic table trends, and column 1 elements form a positive 1 charge. These form a positive 2. Column 3 form a positive 3. Column 4 don't typically form ions. And then for the rest of them, it's negative 3, negative 2, negative 2, negative 1, and then noble gases don't form charges. So sodium chloride is our first example. We're going to write sodium and the charge that it forms when it forms an ion, so positive 1. And then we are going to look at chlorine and the charge that it forms when it forms an ion. Chlorine is in this column right here, so it forms a negative 1 charge. So when we're balancing these to zero, what we're going to do is we're going to put a little space right in front of each one, and that's going to tell us how many of each elements that we need. We said that sodium has a positive 1 charge and chlorine has a negative 1 charge. So positive 1, we're gonna say that the positives and negatives, they always cancel each other. So if one positive charge is going to be canceled by one negative charge. Or we could say we could add these together. Positive 1 plus negative 1 equals 0. 1 plus negative 1 equals 0. So These are already balanced to 0. We just need one of each. You can either write the number or leave it blank. That's totally fine. And then we're going to say that since we only need one of each, we're going to write this as Na. And right here, we're going to write the number of each. And then Cl. And there's only one chlorine needed also. But as you might recall from our last video, if we have only one of something, we don't need to write the 1. This is just NaCl. All right, let's try this again with a slightly more complicated example. Let's do magnesium chloride now. So magnesium, we're going to write magnesium. Well, let's first write what we're doing. We're going to do magnesium chloride. And magnesium forms a positive 2 charge. And chlorine will typically form a negative 1 charge. All right, we're going to balance those out and see what we get. See how many magnesiums we need and how many chlorines we need to balance them to 0. All right, so we have 2 total positive charges and 1 total negative charge. So do we only need 1 of each like before? Let's test what that looks like. If we only have 1 of each, then that means we have a positive 2 charge and we have a negative 1 charge. Notice how the positive charges are going to be canceled by a negative charge, but we have more positive charges than negative charges. How many more? We actually have 1 more, so we have a positive 1 overall charge. And with a positive 1 overall charge, obviously that means that the overall charge is not equal to 0. We need a charge of 0. So what can we do here to get to an overall charge of 0? Should we add more magnesiums or should we add more chlorines? If you guessed chlorine, then you are right. Let's try adding 1 more chlorine so that we have 1 magnesium and 2 chlorines. So with 2 chlorines, we have 2 negative 1 charges. We have negative 1 and negative 1. Negative 1, 2 negative 1s is going to be equal to negative 2. And if we take positive 2 plus negative 2, that's going to equal 0. So we have an overall charge of 0 now. And with an overall charge of 0, that will tell us, since we got an overall charge of 0, that's going to tell us how many of each element we need when building the molecular formula. So the molecular formula here is going to be Mg. And how many magnesiums do we need? 1. But we don't need to write it if it's 1. And then we have chlorine. And how many chlorines do we need? Well, we need 2 chlorines because we said we need 2 chlorines. So if you haven't noticed, the number that is written right here ends up being the subscript for that element. All right, let me move some things around a little bit, and then let's see what our next example will entail. All right, our next example is going to be aluminum oxide, and that's about as complicated as it gets. So all right, we're going to do aluminum oxide as our next example. Aluminum oxide consists of aluminum and oxygen. Aluminum, if we look on the periodic table, it has a +3 charge, and oxygen has a -2 charge. And we need to figure out how many aluminums we need and how many oxygens we need. So we're going to add a little space before each one to figure out how many of each of these we need. All right, so this one's a little bit harder because they don't immediately cancel out. We have 3 aluminums. So we don't have 3 aluminums. Aluminum has a +3 charge, and oxygen has a -2 charge. So +3 and -2. +3 and -2 don't cancel out. But if we think about it, what if we get both of these numbers? What if we get both of these numbers in the exponent? What if we got them to be the same? So what can we multiply the number of aluminums here by to get this number, this 3, turned into a number that 2 goes into? So what we're going to be dealing with is the least common multiple. Or it doesn't even necessarily have to be the least common multiple. We need to find a multiple of 3 and 2. And the easiest way, if you can recall back through math class, the easiest way to find a multiple is to multiply 2 numbers together, because like 3 times 2 is 6. So let's use that. That's the number we're going to be using. 3 times 2 is 6, and 2 times 3 is 6. So 3 times something equals 6, so 3 goes into 6. And then 2 times something equals 6 because 2 goes into 6. Specifically, 3 times 2 is 6 because when 3 is multiplied by 2, it equals 6. And when 2 is multiplied by 3, it equals 6. So 3 goes into 6, and 2 also goes into 6. If it doesn't make sense to you, just remember that in order to find a multiple, you can always find a multiple between 2 numbers if you just multiply them together. It might not be the least common multiple. In this case, it happens to be. But that's always a way to find a multiple. And as long as we find a multiple, then we're going to be okay here. So aluminum oxide, again, this is the most complicated it gets for this kind of stuff. So aluminum has a +3 charge, but we're going to multiply it by 2, we said. So 2 times 3 equals 6, and we're going to keep the charge. So 2 times 3 equals +6. And then what times 2 equals -6? Well, we just said 3 times 2 equals -6. So now that we got this number up here into a common multiple of these 2 numbers, it can cancel each other out. So we multiplied 2 times 3 to get to 6. So we get a +6 charge here and a -6 charge here. If we have a positive and a negative, and they're the same number, then they're going to cancel out and equal 0. All right, and now that they equal 0, now that we got the overall charge to 0 on the left side of the equation, we're just going to write out the number of each element that we have in the compound. And we're going to write that out, and that'll tell us the molecular formula. So we have Al, and we just said that we have 2 aluminums. So Al2. And then oxygen, aluminum oxide. And how many oxygens do we have? Well, we have 3 oxygens. Yeah, and I'm actually gonna change the color to write that in a different color for us. So the I'll write the oxygens in orange so that we don't get it confused and we know where the 3 came from. But Al2O3 is going to be aluminum oxide, and we know that by balancing the ions to 0. And notice that there is no charge written up here because the charge on this side, on the right side of the equation, is also 0. So by balancing the ions to 0, we were able to determine the molecular formula from the name of the ionic compound. Real quick, if you happened to find a multiple of 3 and 2 in this case, that was not the least common multiple, but it was still a multiple. And let's say you found the multiple of 12. Let's say you used 12 instead. Well, 3 times what equals 12? 3 times 4 equals 12, and then 2 times what equals 12? 2 times 6 equals 12, and then you got Al4O6. That's going to work too, but all you have to do is simplify this. So make sure you simplify, and Al4, so simplifying this, you could divide both of those by 2, and you get Al2O3, which is the answer we got. So just always make sure that when you draw out a compound, you have, when you write out the chemical formula always needs to be simplified when we're doing this. So just FYI, that'll be an important concept, but typically for this, you're probably going to find the least common multiple because there's not a ton of examples for this concept. So we should be okay. Just make sure these numbers are simplified.